Welcome to the week 9 video series question number 1. In this question, the simple linear regression model was given, which predicts house price using flow area. Using this model, you need to answer the following questions. So I'm going to explain one by one. The first question is the overall model significant? How can you tell? So using the statistic, we can tell whether the model is significant or not. So the useful statistic for explaining overall model significance is F test. So this F statistic is given the overall model significance. We need to look at whether the significance of F is less than the level of significance or not. If the p-value or the significance of F is less than the level of significance, we can reject the null hypothesis and then overall model will be significant. So in our case, this one is less than 0.05. So we can reject the null hypothesis that the flow area is not affecting the house price. So the overall model significance can be explained by F statistic and the respective level of significance. Moving on to the second question, how much of the variation in house price is explained by flow area? So here the question is asking how much variation in house price is explained by the flow area. If we look at our model, only one variable is used as a regression or the explanatory variable, that is flow area. So the flow area is the only one factor influencing the house price. So the how much variation in explaining house price is given by the R squared. So the statistic that we use for variation in house price is explained by flow area is R squared. In our case, we estimated 0.35. So which means around 35% of the house price variation is explained by the flow area. So the useful statistic is 35% R squared, right? Third question, what does the multiple R tell you? So if you look at this statistic, the multiple R, which is giving the information about the correlation. So basically this gives the information about the strength and the direction of the linear relationship. So in our case, the multiple R is positive 0.5884. So which means nearly 59%. So we can say which has the moderate positive linear relationship because this has the positive estimate, right? If it is negative, we could say it is negative linear relationship. In our case, this is positive. The next question, divide the sums of squared for regression by the total sums of squared. What statistic is identical? So if you look at the output, this is the sums of squared. So the question is asked us to divide the sums of squared for the regression. So the regression sums of squared is this one. The total sums of squared is this one. So 2.96 into 10 to the power 13 divided by this total sums of squared. So which is 0.346. So this is the estimate that the output that has the R squared. So this is exactly same as this R squared. So basically the R squared is regression sums of squared divided by the total sums of squared. So this is manual calculation. This is the one that estimated by the tool. The next question, write out the full equation. How do you interpret the intercept? So as you know, when we are writing the regression equation, we have the dependent variable, that is y. In our case, this is house price. And then we are having the intercept, which is denoted by beta 0. This is intercept. And we estimated the intercept is this one. Plus, this is the coefficient of the variable, beta 1. So we have only one variable, that is flow area. So this is the coefficient of the flow area. And this is the variable, that is flow area. So this is the typical form of the regression. So in our case, the intercept is 63,154.77 and the slope coefficient is 3,472.67. And this x is the variable is flow area. Right? So this is the equation. And then how can we interpret the intercept? Basically, there is no practical meaning for the intercept, but we could say if this component is 0, that means if the variable is 0, then the y is equal to the intercept. But practically, it doesn't mean any, it does not give any meaning. But it is important for fitting the regression line. And then examine the significance of the variables. Examine the significance of the variables. Why is the p-value of flow area the same as the significance of the p-value, right? So the flow area p-value is 1.926 minus 42. The F statistic p-value is same. Why it is same? Here, if you look at the model, only one variable that we are using, that is flow area. So the overall model significance is giving the p-value, this one. Only since it is only one variable, that is the p-value for this one. So in this case, we are testing the t-test. Overall model, we are testing the f-test, but in both cases, we are rejecting the same hypothesis because the p-value is less than the 0.05. So since it is a simple linear regression, we are dealing with only one variable. That's why the f significance of the f as well as the flow area p-values are the same. Use the confidence interval for flow area and estimate 95% confidence interval for house with flow area of 150 meters square. So the estimated equation is this one, y is equal to beta 0 plus beta 1x. This is intercept and this is slope coefficient and this is variable. So this is our estimated model. But now the question is asking with a 95% confidence interval. So with the 95% confidence interval, our flow area has the coefficient, estimated coefficient for the lower confidence as well as the upper confidence. For the lower confidence, the slope is 3025. The upper confidence, the slope is 3920. The intercept is same. So the x variable is 150, which was given in the question. So the lower confidence value is this one, and the upper confidence value is this one. So the confidence interval between these two values. So that's all about the question number 1.